Hello and welcome back to the Pewaukee YouTube channel. In today's video, we're going to look at Leetcode problem 478. It's a medium problem titled Generate a Random Point in a Circle. So let's get started. So our first task, find out what the program is actually asking. Asking us to do. So usually sometimes this might take like a couple of rereads or just a couple times to understand what's actually being asked. So let's take a look. Given the radius and the position of the center of a circle, implement the function randPoint, which generates a uniform random point inside the circle. And implement the solution class, where you have the constructor with, we're going to be using Python for this one, so it's going to be float radius, float x center, and float y center. Initializes the object, the radius, circle radius, and the position of the center. And then randPoint, that function, generates a random point inside the circle. And a point on the circumference of the circle is considered to be in the circle. And the answer is returned as an array. So what it's asking us to do is complete the constructor. The problem is asking us to complete the constructor in which a new circle object, that's not how you spell circle, circle object is instantiated. Okay, and then also complete random point. Which generates a random point in the circle, including the circumference. So really taking example, usually the next step in algorithmic problem solving is using examples, but the examples are not based on an input basis really. It's just you have a radius and you have an x center, you have a y center, but rand point itself is not, it doesn't really make sense. So what I'm going to do is we're just going to look at the two functions. So init, let's make some observations for init, right? So it's pretty simple. Just set all the arguments to self.arg basically. So we can say self.radius equals radius, I'm just going to say x equals x center, x underscore center, and self.y equals y underscore center. So that's simple enough, right? So rand point, basically, when we have a circle, so let's make a circle, and this is a center. Basically, a random point would just be some distance away from that point. So you can go this way, or here, or here, or here, so long as the radius of these lines, so let's say R1, R2, R3, and R4. So as long as all those kind of radiuses are less than the radius in the constructor, then it's fine. Then that's a random point. So basically all we need to do is we need to have kind of like a degrees. So does it go, for example, let's do another circle. So we need kind of a degrees. So if it goes like that, it's 0 degrees. If it goes this way, it's 90, and so on and so forth. 180, 270, respectively. 180 and 270. So all we need to do is we need to select distance, and then we need to um, make sure that the distance away is less than the radius. So how can we do that? So we need a degrees variable. Need a degrees variable. And if we think about, how could we think about this? We could also have a random, also have a random x, and random y less than radius, less than or equal to radius. So all we need to see is that, let's say if we have another circle, let's bring this down a little bit. We have another circle here. If we wanted to travel the maximum x distance from the center, this would be the way to go, because you get the most x distance. And also you get the most y distance if you went on a vertical line to the, points of the circumference there. So how would we figure that out? So now we kind of want to write some small steps, right? Break the problem down into smallest steps possible. So if we say, if we want a degrees variable, so let's do that first. So step 1, a degrees variable. Oh wait, we need to import random. That should probably be the first step. So just import random. And then we're going to say step 2, initialize a random direction for degrees variable. And then step 3 would be to, what would it be? Well, we could have these random x and random y's. So we would say a random x and random y. Yeah, that makes sense. So initialize and assign a random x and random y. Okay. And then we would just need to make sure that the distance, there has to be some sort of absolute value here. Because for example, here in this circle, you could either have the x will be in a positive direction or a negative direction. So it kind of needs to be an absolute value. So we need to say, we need to make a check. And we need to see if, so let's say step 4, determine if the x coordinate, x, random x, determine if random x times sine of the degree. So this needs to be, does that make sense? Actually, I don't believe so. Well, the first check could be that so long as the, okay, hold on. Instead of doing this, we need to make sure that actually the random arguments for x center and y center need to be different. Let's say this point, let's say this center point is at 4 comma 7. Let's say the radius equals 3. So for the x, you would need to say, okay, we can do 3 less than this or 3 greater than this. So our random number x has to be in that range. So the random number x coordinate can be from 1 to 7. Similarly for the y, the random coordinate of x or y would need to be between 4 and 10. So it needs to be minus the radius plus the radius, right? Because that's the maximum range. So here, for example, would be like 10 for the y coordinate, and here would be 4, right? And then here would be 1 for the x coordinate, and here would be 7. So we also need to make those kind of checks. And we need to make sure that we're using our x center and y center properly in our random point function. So let's see. So we have a random direction for degree. I don't know if this actually will matter. I actually don't think it does, because so long as you select a point and it's, when you take the Pythagorean theorem, it's less than the radius, less than or equal to the radius, then you're fine. So I'm actually going to just say, I'm just going to put like that, like comments for right now, kind of just like a comment, or just, putting it down there. Let's delete this step 4, and let's say step 4, make sure, using Pythagorean theorem, Pythagorean theorem, make sure random x and random y subtracted by center, by the center, is less than or equal to, so less than or equal to radius. So now let's try and put these steps into practice, or the last step. So 5, that's readable, there we go, translate to code, right? Translate steps into code. So let's give it a shot. Let's give it a shot by looking at our screen here. So step 1, import random. So usually this is done at the top of the file, so I'm actually just going to do it that way. So I'm just going to do it there. And I'm just going to say import random done at start of file. Trying to, give maximum clarity. Okay, so we don't want a direction variable quite yet, because I don't know if that'll be necessary. So we need a random x equals random.randint. And remember, these are lower bound and upper bound. And we need to kind of think what our bounds are going to be. So we need to know that upper bound is not usually included. So what we need to say is maybe +1. Oh, sorry, this isn't even rand int. That's not rand int. It should be, I completely forgot the second step, which should be make a res array or a result array. So it's going to say res equals list. And then make a random x and random y coordinates. And so what are the lower and upper bounds here? The lower bound would be, wait, it's not randint though. So let me see. Python random Oh, I don't think anything happened. Oh, because nothing was searched. Python random module. So we're just gonna look at, let's see here, rand range. This is probably what we want, I believe. Let's see. Should give me a double as well. 5. Okay, I actually don't know if it does. No, I believe it's just giving me not quite what I want. Let's see. Um, sure, no, not integer. Say Python, how to generate a random double value float range. Random uniform. Okay, so let's do that. Let's use that. So random uniform. So we're going to say using random dot uniform. Actually, yeah, that makes sense. So we're going to say random dot uniform uniform, and we need to say that the lower bound is x minus radius self.x minus self.radius, and the upper bound needs to be self.x plus self.radius. So I believe this should be inclusive, an inclusive random statement, simply because it doesn't make sense not to be. I can't find the Stack Overflow page. I'm opening up Nike. That's not right. Let's see. Here we go. And 1.9. Short answer, yes. Okay, so this is answered. So we do get both of the bounds here. So that's great. And now let's take a look. Let's go full screen again. And so we have random x and random y. Self.x minus, or self.y, the y coordinate. Self.radius. Self.y plus self.radius. And now, the next step. Using Pythagorean theorem, make sure random x and random y subtracted by radius first, or by center points. Center points first is less than or equal to the radius. So basically we want to have probably a while loop actually. So we're going to say while true. And we need to make sure that, so while we don't get valid numbers or valid points. So hopefully this is fine. So now we want to say, we want to check that, right? So I want to say, let me think. Actually, I don't know if we even need it to be, we can just say this. So basically just, we would just want the distance away. So we'll just say distance, oh, I'm on insert, distance away coordinate. So it's just distance away from the center, right? Which is a radius. So we just want to say if, or let's say answer. Sure, let's make a variable answer. Random dot, oh wait, this should be a Boolean. So math dot square root of the I think it's just pow. So just square root. Pow of random x to the power of 2 plus random y power of 2. Oops, I forgot pow. So that's going to return a number, and we want to say if answer is less than or equal to radius, then we want random x to be equal to x center, or self.x, plus random x. So we can just say plus equals self.x. Because now we want to set it relative to the circle. So it's a random y plus equals self.y. And then we're just going to say res 0. Actually, we can just say something like this, 0, comma 0. We could say res 0 or 0 equals random x. Res 1 equals random y. Something like this. And then we want to return the res. Or we want to break. We want to break from the while loop. And then we say return res. So let's see what happens if we try this out. Invalid syntax. Oh, I forgot self.radius. Believe. Oh, and there's no brackets in Python. That's something. Oops. I'm thinking Java things again. That's no good. So we'll say self.radius too, and then let's see what happens. Okay. Seems to run the first case fine. Let's try and submit. All right, fantastic. So we got done with a medium problem today. Pretty proud of myself for that. And I believe in pretty good time. So 23 minutes, that's very nice. So basically a run through again is that we want to use random to find a random point, the random module, and we're going to use this uniform function. And we are going to just find first the distance away from, I guess, the center point, which is just the radius, in simpler terms. And then we want to use the Pythagorean theorem to make sure that the random x and y subtracted by the center points actually, we can just say is less than or equal to radius. So using Pythagorean theorem, we just want to make sure that the random x and the random y, when it's taken into account, is less than the radius. So we're able to do that, and we're able to get a correct answer. So let's see some other answers from other users. I like the fast runtime ones. Let's see. Angle and radius. Okay, these guys use angles. So they use a radian, 2 pi. Scale equals math dot square root of random uniform 0, 1. Okay, yeah, they're using the cosine and sine. That's a very good way to do it as well. So all they do is they get a random degree. And yeah, okay. That makes a lot of sense. I think this is the best way to go about it. Good on this person. But we also found a different way, and it did work. So, alrighty. Thanks for watching. See you in the next one.